Hi, during this session, we're going to go through some of the things in your data analysis assignment for project 2. So I'm just going to use an example of a sample of M&Ms that I had. These are plain M&Ms. So the first part of that was to choose a confidence level and a maximum margin of error that you would be using for your confidence intervals. And then the idea with that is to put that into the formula for the minimum sample size and make sure that you have a sample size that's big enough to use those parameters for your confidence intervals. So my sample size that I have is 349. And I decided to make an initial choice of using a 97% confidence level and a 3% maximum margin of error. And when it says the maximum margin of error, I want you to be sure and hear this, that the margin of error you choose here is just a maximum margin of error. When you actually calculate the margin of error later in this assignment, it is not necessarily going to come out to be exactly the number that you chose here. It should be no more than that. So for most of you, it should come out to actually be a little bit less than that number. If you're just plugging in the number you choose here as your margin of error, then that's not actually calculating the confidence interval. So that's not what you're meant to do with this. Anyway, so the idea is to take these two choices and then use the sample size formula and see what that comes out with for what the minimum sample size would be for this. Okay, so here's the formula. So I'm going to plug all these things into this formula. And there are a couple of other values that I have to put in here. So for the 97% confidence level, I'm going to use that to find my critical value, so my z of alpha over 2, which goes into the formula right here. The maximum margin of error, that's going to be the E in the formula. But one thing that's very important whenever you're talking about formulas that have to do with proportions is if you have a percentage like this, you have to change it to a decimal. So to use this in the formula, we're going to have to change it to 0.03. So that will be the E in the formula. The other thing I have to do is look up that Mars Company letter, because the P star in this formula is a prior estimate of what our proportion might be. So for this, I'm going to look at my Mars Company letter, and for the variety of M&Ms I chose, which in my case was plain M&Ms, I'm going to look in that letter and see what the biggest percentage was for any of the colors. So for me, for the plain M&Ms, the largest percentage listed in the letter was 24%. So I'm going to use that for my prior estimate. So I'm going to use, and again, I have to change this to decimal to put it into the formula. I'm going to use 0.24. Okay, so with those things, I can get all the numbers I need to put into this formula. I have the E and I have the P star. The only one I need to actually find is the critical value. So I'm going to go back to my confidence level and go through all the steps to find my critical value from that. So if my confidence level is 97%, that means my alpha is 100% minus that. So that would be 3%. And again, I want to put this in decimal form, so I'm going to make that 0.03. That means my alpha over 2, I just take this and divide it by 2, so that's going to be 0.015. To find the z-score that goes with this, since we're talking about standard normal distribution, here's my picture. I've got my normal distribution with 0 in the middle, since that's the mean. The easiest way to do this is find the cutoff value in the left tail, so that the area in the left tail is my alpha over 2. So to do this, I'm going to use the inverse norm function on my calculator. For this one, I just have to put in the area and then the mean and the standard deviation. And in this one, it already has my mean and my standard deviation as 0 and 1. So actually, all I have to do is put in 0.015 for my area. Okay, so let's see if I can get this where you can actually read it. This is what this would look like. I'd have inverse norm, 0.015, a comma, a 0, a comma, and 1. That's going to give me a negative number. For my critical value, I just take off the negative. So I'm going to take that and round it to 2 decimal places. So that means my number over here rounded to 2 decimal places is negative 2.17. I have another one on this side that would be positive 2.7. So that gives me my z alpha over 2 of 2.17. Now I'm going to use my formula over here. And just plug in all of the numbers that I have. And again, everything in this, if it was a percentage, it has to be in a decimal form. So I'm going to take my 2.17, I have to square that, and my p star was 0.24. And then I have 1 minus 0.24. My e up here was 0.03, and I have to square that as well. So I'm just going to take those things and plug them into my calculator. And I'm actually just plugging all of this in at once. I'll put this up here so you can see it. I'm doing it all in one line. And then with this, what comes out is 954.3. When you're doing minimum sample size, you always have to round up to the next biggest integer, so this would round up to 955. Okay, that is way bigger than the 349 that I actually have in my sample. I don't want to go back and buy a whole bunch more M&Ms to get it up to that amount of M&Ms. Even though I like chocolate, that seems like an awful lot of M&Ms. So I'm going to go back and change some of my design choices up here and see if I can get this down to a reasonable number that's less than the amount I actually have in my sample. Okay, so I can change either one of these things. If I lower my confidence level, that's also going to lower my minimum sample size. If I increase my maximum margin of error, that's also going to lower my sample size. So I gave you an example in the actual data analysis assignment. So I'm going to do a couple of other examples. Let's say that I just change both things. Let's say that I decide to use a 95% confidence level and 4% maximum margin of error. Okay, so that means I have to go back and recalculate some things. I have to go back and find another z alpha over 2. And this means that I'm going to use E equals 0.04 in my formula. So for this one, my alpha is 5% or 0.05. So my alpha over 2 is 0.025. Then again, what I'm doing with this is I have my normal distribution. I want to know the cutoff value right here so that my area in the left tail of this is 0.025. So I'm going to go back to the inverse norm and put in 0.025 instead of the number I had in there before. So here's what I would have on my calculator. If I do that, it gives me negative 1.96 if I round it to 2 decimal places. So my critical value is that, just with the negative taken off. So now I have z alpha over 2 is 1.96. My E is 0.04. I'm still using 0.24 for the prior estimate. Okay, so I'm going back to this formula and I'm changing these two things. So I'm changing this to a 1.96 and I'm changing this to a 0.04. I do all that, I get an answer of 437.9, which I would have to round up to 438. That's still too big because my sample size was only 349. So I have to do some other kind of change. So the basic idea of this is to keep going, change your design choices until it matches what you have in your sample. And it doesn't have to be super close to it. It just has to be less than what you have for your sample size. So let's see. Let's change just the maximum margin of error to 6% and see what that does. So I'm going to leave my confidence level at 95% and change this to 6%. So that gives me 194.6. I would round that up to 195. So that's acceptable with the sample size that I have. Because this is less than the sample size that I actually have. So that one is going to work. So for this example, I'm going to decide based on that I'm going to use a 95% confidence level. And what I chose for my maximum margin of error, I'm not actually going to use that in my calculations for my confidence interval, but I should know when I come out with my confidence intervals, that should be the biggest possible margin of error I would get. If I come out with something bigger than that for my margin of error, then I've done something wrong. So my margin of error that I come up with should be no larger than 0.06. Okay, so